Okay, X-intercepts are the X-coordinates of points where a graph intersects the X-axis, and Y-intercepts are the Y-coordinates of points where a graph intersects the Y-axis. Recall that we had seen that a point is on the X-axis if and only if the Y-coordinate is 0, and a point is on the Y-axis if and only if the X-coordinate is 0. That all seems a little backwards, but both of those sentences that we saw last time mention x once and y once. So on the x-axis, the y-coordinate is 0. That makes sense, right? Because all along the x-axis, the points have no height, right? And the y-coordinate tells you how far up or down you go. So that 0 means you don't go travel up or down. So you end up on the x-axis. So how do you find x-intercepts? To find x-intercepts, you should set y equal to 0 and solve for x. Why does this work? Well, um, to find x-intercepts by definition. So an x-intercept by definition up at the top here, I've highlighted in red. That is a point that's on the x-axis. Well, if we want a point on the x-axis, to be on the x-axis, due to this if and only if thing, the y-coordinate has to be 0. So since y must be 0, that is why we set y equal to 0. Similarly, in order to find y-intercepts, you set x equal to 0 and then solve for y. This all sounds so backwards, but it goes back to things that we've already seen. So it seems a little counterintuitive, but to find y-intercepts, you need to set x equal to 0. To find x-intercepts, you need to set y equal to 0. So let's try this in an example. Find x-intercepts and y-intercepts of the graph of 2x plus 1 equals y squared minus 5. So let's start by finding x-intercepts. For this, we need to set y equal to 0. Okay, so take the equation at the top, set y equal to 0. You have 2x plus 1 equals 0 squared minus 5. Simplify the right side. Let's subtract 1 on both sides, divide both sides by 2, and x equals negative 3. Cool. So that's the only x-intercept. X equals negative 3. Now, what about y-intercepts? Well, for y-intercepts, we're going to need to set x equal to 0. In the original, right? So go back to the original equation up here. We could have done the finding of x-intercepts or y-intercepts in either order. So you got to go back to the top. We can ignore all the work we've done otherwise. So set x equal to 0, and the left side's going to simplify to a 1. Let's add 5 to both sides, and then square root both sides. So y equals plus or minus root 6. So there are actually two y-intercepts here. Y equals root 6, y equals negative root 6. Here's a picture. There it is. So I asked the computer to just graph this equation in x and y. So it's all these points satisfy this equation. And we saw the only x-intercept was at negative 3. We saw y-intercepts of root 6 and negative root 6. So as a point, it was x-coordinate 0, and then y-coordinate is either root 6 or negative root 6. So those are drawn. The computer decided to give these as approximates. Apologize for that. But those are the two y-intercepts, and then here's the only x-intercept. Okay, last time we used the Pythagorean theorem to learn the distance formula, right? The distance between 2 points looks a lot like the Pythagorean theorem, but that square root all around the outside is because we had to undo the square on c squared in the Pythagorean theorem. There's no distributing here that's allowed. So for instance, the distance between the point 2,3 and 7,9 is shown using the distance formula here. I just thought for the sake of what we're going to do next, I did not bother simplifying this. Also, let's change up the question a little bit and talk about the distance between the point 2,3 and an unknown point x comma y. So instead of 7,9, just switch it to xy. Hope it makes sense that then the distance is root x minus 2 quantity squared plus y minus 3 quantity squared. Now, a circle, we just think of it as something that's round, but there's an actual definition which says that a circle is a set of all points in the plane that are a fixed distance from a specified point. That fixed distance is called the radius. The specified point is called the center. So let's explore. Let's make an equation for a circle of radius 7 with center 2, 3. So we need all the points that are 7 units away from 2, 3. Right? So you start at 2, 3. That's one point in the plane. And then if you were to attach a string of length 7 and you're trying to get all the points that are exactly 7 units away, we just want all points xy whose distance from the point 2,3 is 7. Yeah, we need the distance between the point 2,3 and some other generic point x comma y to be 7. but we just computed the distance between 2, 3, and x comma y. That was in yellow up there, so that's just been recopied down here. And that must be, so the must be is the equal sign, 7. So this actually is an equation for the circle. What we usually do, though, to create an equation for the circle, again, it's not valid to distribute the square root sign, but what we tend to do is square both sides and have x minus 2 quantity squared plus y minus 3 quantity squared. Oh, the large square root on the outside is gone because we squared both sides, and then the right side no longer says 7, but now says 7 squared, again because we squared both sides. So let's write an equation for the circle centered at 8, 6 of radius 9. Well, the distance between the point x, y and the point 8, 6 must be 9. So in other words, distance formula applied to x, y, and 8, 6 must be is the equal sign 9. And so that looks, so we set that up, and then the most usual form is to square both sides. So we have x minus 8 quantity squared plus y minus 6 quantity squared equals 9 squared.